So let's look at another example of static equilibrium. What force is required by the biceps muscle to hold a 4 kilogram book when the arm is horizontal with respect to the floor if the biceps is attached 5 centimeters from the elbow joint? Assume the forearm and the hand have a mass of 2 kilograms. All right, let's do a little anatomy here for a minute. When you bend your arm at a right angle at the elbow to hold a book level with the floor, do you know what's actually going on there? Your biceps muscle is the one in the front that bulges when you flex your arm. It does that because the muscle fibers are contracting. The end of the biceps muscle is attached to a point on the 2 bones of your lower arm at a point called the insertion point. The 2 bones in the lower arm are connected to the bone in the upper arm through a flexible joint called your elbow. When the biceps is flexed, the muscle contracts, providing an upwards force on the insertion point and causing the arm to bend at the elbow joint. In this problem, we are looking for the force that is exerted by the biceps muscle to keep the forearm horizontal. This force is acting in an upwards direction at a distance of 5 centimeters from the elbow, which is the pivot point. The weight of the arm itself is acting to pull the muscle down. The center of mass of the forearm is defined for us at 16 centimeters from the elbow, so the force of the weight of the arm is acting here. The third force is the weight of the book acting to push down on the hand at a distance of 36 centimeters from the elbow. Since this is a rotational motion, we are actually looking at each of these instances acting as a torque. The total torque is the sum of all of the torques, and since the arm is held steady, the sum of all the torques will be 0. TB is the upward torque supplied by the biceps muscle, and since it acts in the up direction, the resulting torque would be a counterclockwise direction, so it will be labeled as positive. TA is the torque from the arm itself, which tries to rotate the arm in a clockwise motion, so the torque would be negative. And then T(b) is the torque resulting from the weight of the book that would rotate the arm clockwise, so it is also a negative torque. We can rearrange this so that everything is positive by subtracting the torque of the book and arm over to the other side. Torque is found by taking the force times the radius, so we can substitute those in for our torques. The force of the biceps is actually what we're looking for, so we can divide by the radius of the bicep. Then it's just a matter of plugging in what we know to find 376 newtons of force.